Hi there, I'm back and we're doing more of the multiplication of fractions. So just to quickly review, if we are doing 3/4 multiplied by 4/5, what do? So we know that the second one, this is going to be our base, so this is what we are going to represent as an area model. And I have 1, 2, 3, and 4, so I divide it into equal sort of and parts. So I have 5 equal parts, and then I am going to shade 1, 2, 3, and 4 to represent 4/5, right? And then remember, because we dissected this area model for our 4/5 from top to bottom. For the next bit, we are going to do it side by side. So what happens is we are going to do this way. So so side to side, and we want to figure out what is 3/4 of 4/5. So once again, what we're asking here is 3/4 of 4/5. Okay, so I just divided the green, the parts that are colored in green, that's the 4/5, and then I divided that into 4 equal parts. So as you see, this part is 1/4 of 4/5, and again, this is again another 1/4 of 4/5, and again here I have another 1/4 of 4/5, and now I have 3 1/4 bits. So that means these bits right over here, so da 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 da, these bits right over here. Now it's sort of really dirtily colored, but the parts that are colored in blue, those units actually represent 3/4 of 4/5. So we know that we divided this side into 4 equal parts and this part 5. So we know that unit fraction right over here is 1/20th, and we colored in blue 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we colored in 12 out of 20. Sorry, I'm spitting. So it's 12 over 20. 12/20th is the, I can't see, is the answer to this question. But then what happens if one of these fractions is actually bigger than 1? How does that change? So I'm going to show you that next. So I'm going to erase this bit now. Okay, so for this one, once again, how do we read this question? We want to figure out what is 3/4 of 6/5, right? And once again, as we've been doing, we will represent the second part. We're going to just call that our base, and we're going to represent our base fraction in an area model. Hey, is that enough? No, because it's bigger than 1. That means we need 2 wholes to represent this. Okay. Okay, kind of uneven. Let's pretend that it is even. Okay, so now we have to represent 6/5. So, well, we definitely have to color in 1 hole, right? Because it's bigger than 1. So here I just colored in 5/5. That's our hole, right? Just our 1 hole. And I still have to color in one more little bit, because that's our 1/5. So now we have represented 6/5. So what is 3/4 of 6/5? So as we've been doing, we dissected both of our holes from top to bottom. So to see what happens for 3/4 bits, in order to figure out what is 3/4 of 6/5, we will dissect our area model side to side. Okay. And I have to figure out what is 3/4 of 6/5. So first we're going to figure out what is 1/4 of 6/5. So I divided the parts that are colored in green, that's the 6/5 part, right? And I divided that into 4 equal parts. 1, 2, 3, and 4. That means right over here, that is my 1/4 of 6/5, right? And this is another 1/4 of 6/5. And once again, right over here, 1/4 of 6/5. So now I actually indicated what is 3/4 because I have 1, 2, and 3 bits of 1/4 of 6/5. So I have indicated what is 3/4 of 6/5. So I can just color in just to make it clear. This bit, this bit. Okay. Bear with me, just coloring in that. And okay, so we're going to figure out what the unit fraction is. Our unit fraction is, so I divided this side into 4 equal parts, and this side 5. So 4 times 5, unit fraction is 1/20, 1/20th. So I know that my denominator is going to be 20. And how many of these little units that did I color in? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and 18. Okay, so I colored in 18 out of 20, so 18/20th. And I can divide both bits by 2. Both bits by 2. Remember, if I do either a division or multiplication, I have to do the same division or the same multiplication to both the denominator and the numerator so that the fraction doesn't change, the ratio of the fraction doesn't change. So I know that is 9/10, 9/10. So that's the answer to this question. Now I'm going to ask you, do you think I can flip these two and still represent this calculation? So I'll be back to show you what happens when we flip these two, and I also come back to show you that we can do the same thing when both of the fractions are bigger than 1. Thank you. Bye-bye.